that we have trained our language model, okay? And we have done with the same dimensions and the same size of data that people did GPT-3, for example, or GPT-4. Then the question coming to mind is that what's going to happen if I just ask this language model a question? Is it going to answer me exactly the same way that ChatGPT is doing? So the point is that it's not going to do it immediately for you, because what you have trained is essentially a text completer, right? So what you have trained is that this model is going to learn to complete the text. But I told you that this is enough if you want to do anything else, yeah? And we're going to see why this is enough today. So, for example, say that you ask this question from this trained language model. And don't laugh, I know that you ask it, yeah? How can I get rid of Ali Barehi, right? You go train that model with the huge data and you ask this question. But your model is not going to give you the answer like you mean, right? It's going to give you this is going to complete this text, right? So it's going to add extra description to the same text because this is a valid completion of the text. So it's going to put something like this, for example, Ali Barehi, who works at the EC department, UofT, kind of annoying, especially applied deep learning, always talking about backpropagation. So you're going to put information about me, right? So this guy is knowing that it's because you're not specify the model to just answer questions, right? You just told it, just learn how to complete a sentence, and this is a very valid completion of the sentence, right? The facts are true, grammatically it's correct, so there's no reason that it's not coming out of the model, right? So your model, which you have trained, is able to complete the sentence, but still, if you're looking for answers of questions, you're not getting the answers. Yeah? So this is the issue, and then the question is that how we can make this guy into the architecture which can answer questions. So this kind of model, which you have trained to complete the text, is what we call it pre-trained LLM. And the pre-trained term is not new to you, right? For instance, when you do supervised learning, there is pre-trained version of ResNet being trained on ImageNet, right? And then you're going to do a bit of fine-tuning on that to make that fit to your own data set, which is, for instance, CFAR, right? So same thing here. This is pre-trained for the task that you have trained this model on, and that is completion of text, right? And now you want to get it and make it, for instance, into a new model which is able to answer questions. Everybody's clear? So this is the thing that we want to do. So pre-training is essentially nothing but training your text completion language model. So the basic thing you think about language model is the pre-trained language model. And now what you want to do, you want to essentially get from that one and get into a kind of model which is capable of doing one specific task you are looking for. Now, how can I formulate this problem? So let's get back a bit into this statistical representation we had. So we actually got the model and we somehow trained it on huge data, right? That data includes every kind of text you can think of, and then your model has learned to somehow complete text according to that data, right? So it's a kind of what I call it a generic language model, because a generic language model has no, specific goal in it. It just wants to give you a right sentence, right? So this is a kind of probability distribution which says, okay, this is the token sequence, and what are valid next tokens? I'm going to put them right after, right? So I'm not going to give you a wrong sentence, but I'm going to give you one sentence, right? But what you're looking for one task-specific distribution. And what do I mean by task-specific distribution? I mean that maybe you are giving the same input, but this time you don't want to look at any right completion. You want to find the right completion, which is the answer to that question. Because the answer to the question is, again, one right completion, right? Yeah? So if you ask the question, the model could also come up with this completion that the answer to this question is blah, 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 right? This is not a completion, and this is not wrong. It contains the meaning, it contains right grammar, so it's another one. But you are looking for that one, so you're looking for some specific P, some distribution, which is giving you always answer to the question, right? So you're looking with what I call it task-specific distribution. So the task here is to answer the question, and what you are looking for, you want to find one output, one sample, which is not only completion, but also right response to that input, right? In the kind of task you're thinking of. So in the example we had, for instance, if you give this question, you want it to just give you the answer. Just ask questions, right? So ask question, he's going to speak less, you're going to get rid of him, right? So again, there is no unique answer to this very complicated question, but there are a bunch of answers, right? And you want your model to give you one of those answers, not going for some completion of the sentence which you are not considering it an answer. Everybody's clear what I mean by task-specific distribution? So I know this is like a kind of mathematical notation here, a distribution, but the distribution here for you simply means that giving a kind of valid answer, right? So always think of one example in your mind and everything gets clear. Yeah? Okay, great. Any questions? Ask questions, yes.
Are we changing our tokens to something task-specific?
We're going to talk about it, yeah. This is one solution that we can do, but this is not the first solution comes to mind, yeah. But that is a valid answer, yes. Other questions? No questions. Great. So now let's start with the idea of fine-tuning. So the first thing that came to mind is that, okay, well, we do know it from supervised learning as well. There we get a model and fine-tune it, right? Maybe we can do fine-tuning. And this simply means that, okay, we have a model, and this model is able to complete the sentence. So it knows the general distribution of a language. And the answer to a question, the distribution of that particular task, is pretty much very close to that other distribution, right? The generic distribution of a language. Because again, answer to a question is one of the valid completion of the sentence, right? So maybe this is the case. So maybe we start from this pre-trained model and then we fine-tune it. And what do we mean by fine-tuning? It means that we're going to get a bunch of samples. We put them as a kind of like question answers, and then we keep on training our model now only on this data, right? We start from the pre-trained language model and we keep on training it in that way, right? So the idea here is that your model, your language model, is capable of generating meaningful and grammatically correct completion to the sentence. And now you're looking for that completion which is really related to the task that you're looking for. Because your language model is capable of extracting the context, right? So it does understand what you're talking about. The only thing is that you want to make it understand that I want you to always answer, treat it as a question and answer it, right? So you want your language model to go that way, right? Now, the point is that your model has not been yet clear about the kind of task you are looking for. So the desired task is not clear here for your language model, but it's capable of generating valid solutions, right? Valid completions. Now, as I said, this is the idea of fine-tuning, so maybe we can go ahead and collect a bit of task-specific samples and keep on training what already has been trained on the general language corpus for this particular task. And I do know that most of you have this idea in mind, but just to indicate, fine-tuning simply means that you keep on your training, but then you just use a tiny data set which is specific to the kind of distribution you are looking for. Yeah? So only containing questions and answers. Okay, questions? Everybody's clear? Okay, so let's first look at GPT-1, see how they have done it. So this is GPT-1. They trained it 12 layers of this, transformer layer, 12 layers of that, and then finally they get the probability of the next token by using a feed-forward layer here. So this is the GPT-1, and they train it. Okay, they have already trained it, meaning that every weight here is now fixed and is able to complete a sentence. Okay, Now, they wanted to fine-tune this guy. How did they do that? So they started to collect a bunch of, what we call it post-training data set. So post-training samples, they just collected a bunch of questions with valid answer. What is banana is a fruit? What is inside a particle? It consists of atoms and molecules. Things like this, right? So questions, valid answers, right? And there is, of course, no single answer to a question, but, a bunch of them, right? So say are different question and answers, and then they wanted to somehow fit it into this guy to get fine-tuned. What did they do? Well, they started to make a kind of token sequence out of these questions and answers. The token sequence was starting by some starting token. Okay, it could be a single token. We don't have a battery.
Your call is being connected.
Sorry. No, I don't want. because I want to make it clear and then. Let me just use this microphone. Yes, this is working. So I'm going to use this one so I cannot jump up and down till the answer. So sorry for that. Now, they started by putting here a starting token. So this starting token is something you choose, right? It might be one single token, it might be a bunch of tokens. And is it from the already available tokens or is it totally new tokens? In their initial proposal was a new token, right? But you can come up with a one specific token you have in your vocabulary. It doesn't matter. So there's one starting token, and then they put right after that the question. The question comes after the starting token. The question is over, then there's gonna be a delimiter. So yeah, right after that the question was in, and then after the question is over, then there is a delimiter. Delimiter is again a kind of token. You define it, for example, right? In the original proposal it was the $sign. But you can put any, you might define a dummy token and you put it as the delimiter. Again, you can put in multiple delimiters. It doesn't matter, right? So it's your choice. And then after that, right after that, the answer comes. And then finally, there is one end token. So there is one token, which indicates is end of the answer, right? Now, this is the kind of sequence they are giving to the model. Yeah? And they are training the model on this one. And do you understand why this is a good kind of token to get fine-tuned on, token sequence? Because your model, so your model is going to start with the starting one. It sees the question, then it gradually starts to learn that whenever it gets to the delimiter, then it should collect whatever context is here, it treats it as a question, and then it's going to write it down, give the answer right away in the answer side. You clear? Yeah? So this is somehow artificially making your model understand that the completion should be an answer. Okay, so sorry guys. So yeah, this was the, you got the idea how we're building our sequence, right? So now we are building a sequence which is start with the starting token, question, delimiter, answer, and then we are going over it, right? And when we are going over it, we're not doing anything different from what we did before. So our model gets this token, and it starts to somehow get trained to generate every next token, right? And if it's trained very well on a good amount of data, then gradually it starts that, okay, whenever you start from the start point, then you go till you get to the delimiter, you treat everything as a question, and then you start generating a valid answer, right? It's the right completion given this structure of the data, right? So this is the way that they made their sample inside the fine-tuning data set, and then they actually just fine-tune the model on this one for not so many epochs, and then after gradually it started to do the job. Yes, you have a question? It's going to be generated, but it's not very hard for you to remove it, right? So you're gonna give the question. I'm gonna explain it now. You're gonna give the start point question delimiter. This is the incomplete question, token sequence, right? And then you're gonna get that one, and now it completes it with the answer. Then you can extract the answer out of it, right? Dollar sign, yes, of course. But the point is that, I mean, you're going to tell your front end that whenever you see dollar sign, ignore it, and whatever is after dollar sign, copy it as the answer, right?
Yeah, I just mean like that means generically the output. You can't expect your model to model generate.
Oh, yes, yeah, I got it. Yeah. I mean, this is why I told you the best idea is that you define your own token, right? This is going to reduce the risk that if there is a dollar sign inside the question, then you're going to get confused with that, right? But in the very original example, they were doing it on a simple data set, so they didn't have this issue. But your question is right. If I just choose one available token from my vocabulary, then there is the chance of this issue happening. Right, right. Yeah. It was just the initial proposal, because GPT-1 was only showcasing that everything is working. Yeah. Yes? Yes. No, it's only questions and answers. So you have already trained on your main corpus, so this is capable of completing. No, the post-training is only question and answer, and this is totally task-specific if you are looking for question and answer.
And the prompt is always a complete question, and the text to be completed is always a complete answer. Like
Yes, yeah, exactly, yeah. Then later you start to sample from it, of course, and then hopefully the samples are valid answers, yeah. But in your data set, you have complete question and complete answer, right?
And how do you make the batches the same size? How do you make the...
Oh, you don't really need. You usually put a maximum size, right? And then whatever is smaller, then you put empty token, right? Yeah. Questions? Okay. So this was the way that they did it, and the point was that, well, the model is now, as I told you, is seeing the question, the limiter, answer, and it starts to mimic that behavior. We usually call it supervised fine-tuning, and the reason is that for the task that we are fine-tuning, we have the data sample, which is the question, we have the label, which is the answer, right? This is why we call it supervised, because we have both the question and answer, right? Both the data and its label, right? So, but at the end of the day, we're just fitting it into our data, into our language model in the same form that it was trained on, right? Initially, the pre-training format. So this is the first thing. The other thing is that when we do post-training, when we do fine-tuning, we are really dealing with significantly less data. So, for instance, for GPT-1, this particular example I gave you here, it was the race data set, which contains 100K different questions and answers. And the number of epochs that they have fine-tuned on this small data set, relatively small data set, was 3 epochs only. Yeah? So you don't really need to wait forever for fine-tuning. It's going to happen quite fast. And this is significantly shorter amount of time and amount of data as compared to what they needed to make the pre-trained model. Clear? Great. So one thing that I want to indicate here, of course, I'm giving you the example of question and answer because that is very intuitive, but you can use it pretty much for any task. Yeah? Maybe you want to just classify a text. Well, you can put your text delimiter, and then you put right after it the class of this text is the label, right? And you make a lot of that, right? And then you fine-tune your model on that one, then this model is capable of doing the classification, right? So maybe you can do similarity check, right? First sentence, delimiter, second sentence, delimiter. The similarity score is label, right? And you make a big data set, bunch of them, right? You do fine-tuning. This starts to understand. It's going to see the first sentence, second sentence, compare them, give you the similarity, right? So you see that you are going beyond the simple completion, right? Because you can somehow fit any kind of task into this specific format of sentence completion, right? And this is the magic happening here. It's not really magic, but if you don't know statistics, then it sounds like a magic, right? Because the model is somehow starting to understand other tasks as well. But the reason is simply because the other tasks are, again, some language-dependent distributions, and you're essentially just making your model to understand that among all possible outputs you can give me, I'm looking for those particular ones which are related to this particular task. Yes? No, it's usually not the case. It's typically not the case. I mean, they are. I mean, the whole magic or the whole reason that they got interested on the story was because the post-training was significantly shorter in time and computation. It's uncomparable to that one. And this is why they felt like, okay, if you train this language model on a huge data, then it's essentially able to get adapted to anything, right? And this was the moment that they said, okay, AI can do what human can do, right? Yeah, it's a strong foundation. This is why we later call it foundation model. Yes, exactly. So we're going to talk about this. No worries. Any other question? So just a short follow-up on that. Now, say that I did the fine-tuning and I want to just get the answer to one new question. How can I prompt from this model? Okay, essentially, it's not hard for you to think what we are doing here, right? So you're going to get this model, which is now trained. So all the weights have been updated based on those question and answer data set. Now you have a new question. Say you have question star and you're looking for the answer. You just put it in the same structure, right? So you're going to put it in this form. So the start point, question, delimiter, and this is your incomplete sentence, right? You give it to your model, the fine-tuned model, and it's going to complete it. And how does it complete it? Probably after seeing delimiter, you're going to put the answer end, right? And then you're going to see whatever is between delimiter and end, and you're going to take it as the answer, right? So problem solved. Now it can answer your questions, right? So if you ask the same question we had beginning, I'm going to give you the right answer. Okay, so yeah, I'm going to give you a break, few minutes. Just I just formulate everything in a general format here. So again, a bit of practice on what we like modeling everything that we had here in a statistical form. If we want to do it, then basically we need two basic definitions. The first one is the pre-trained distribution. So what do I mean by pre-trained distribution? I simply mean the large language model which has been pre-trained. Yeah? So it has a distribution. It's going to compute always a distribution. That is the pre-trained distribution, right? So that distribution is being a function of your weights, right? These are the weights inside your large language model, the transformer weights, right? So this is your pre-trained distribution, and then you have a task-specific distribution, right? The distribution which is going to get a prompt, a question, and then the output, the response, is the right answer to that question, right? This is a distribution which is in general probably different from the pre-trained distribution, right? And what you want to do, you have this distribution, you want to somehow push it to mimic this distribution, right? So you want your LLM now be able to somehow behave like that distribution, give answer to questions, right? Well, how we do it, we just do the fine-tuning, right? So the fine-tuning, essentially, we get our pre-trained large language model. This is one thing. We get a bunch of samples from task-specific distributions. I mean, samples from task-specific distributions sounds very fancy, but basically I mean question and answers, right? I'm going to collect a bunch of question and answers, right? I'm going to collect them, and then I'm going to do, first of all, I'm going to put it in a kind of a structured form, right? So a structured form exactly is the start, delimiter, end in our GPT example, right? I'm going to do the same thing here. So in general, I can think of any general structure which gets the data, the sample, and its label, the question and the answer, and put it in a right format, right? And once I made this, I'm going to make a new data set. And this data set consists of only those post-training samples, those question-answer structured ones, right? And I keep on training on this architecture. So this F here is essentially what we had in GPT. And one example, those delimiter and start points. And it doesn't matter really which one I'm looking to. If I have my question and answer, I can make the complete structure sequence. If I look at this structure sequence, I can get back to my question and answer. There's always one-to-one connection here. And then once I have the data set, I just keep on training on that one, right? For a few number of epochs. But again, data is significantly smaller. And also the number of epochs I need to go over it is significantly smaller, meaning that I'm going to just get fine-tuned quite fast, right? So in the example that we had right now, so our pre-trained model is essentially that GPT-1 model, which has its own weights. And then we have collected a bunch of question and answer, right? Each question is the data, the answer is the corresponding label. And what we did, we just put it in the right order, right? So that F function, a structure function, is essentially the order that we made. And then finally, we made this post-training data set. We just trained over it for multiple epochs, right? And then when we wanted to sample from it, what did we do? We just put the question in the same format as we had, and then we gave it to the model to complete it, and then it gave us answer, right? So same thing we can do again here. So once I have done the fine-tuning here, I am going to have a new bunch of weights, so W tilde. So the weights have changed because I have done a bunch of extra epochs now. Yeah? And this new model is going to represent the fine-tuned version for me. I'm going to use this one to get the answer. So I'm going to get one input to this model, and this input is going to be made out of the new prompt that I have, a new question that I get, and I put no label for it, right? Because there is no label. I want to know what is the label, what is the answer, right? So I'm going to make the incomplete sentence by having only the question in the right structure, which is given by F. Then I'm going to use the fine-tuned model to complete that one, right? So that guy is going to get start, question, delimiter, and then it gives me the answer end, right? And out of that structured version, I do know where to look for the question, the answer, so I'm going to take out the answer, right? So this is how you sample from a fine-tuned model. So essentially what we did before is completely explaining what I tried to explain here for you. So here, after doing the fine-tuning, I'm going to have a new model. That model has a kind of fine-tuned weights, right? And these fine-tuned weights that I have, if I want to have a new answer to a new question, I'm going to put it in the right format. No answer here, right? So empty. Everything is empty here. And this guy is going to complete it. And once it's completed, it's going to put the answer and end token. And then out of that, I can get my label, right? The answer. And you can extend it in your mind to any problem. Problem of text classification, right? You can do it in the same way, right?